So another thing that a Thevenin equivalent is good for is you can find the maximum power that can be transferred to whatever load that you're putting on the circuit. And then I have up here just a little derivation of it. Y'all probably did it in class as well. I doubt that you'll have to derive it, but it's not that hard to do, so you can figure it out. But you have maximum power. You get maximum power when R Thevenin. Well, it's really because you're setting the load. You don't determine. Well, I mean, I guess you could do either one. So I guess, but I was going to say when RL equals R Thevenin. So when whatever load you're applying with the resistor, if that has the same resistance as R Thevenin, then that's when you get maximum power. And what is that maximum power? The maximum power is equal to V Thevenin squared over 4RL. So that's just a handy formula to use. And so in this problem it says, for the circuit shown, find the value of RL that results in maximum power being transferred to RL. So we want to find the value of RL that results in maximum power. Well, we get maximum power when RL equals R Thevenin. So let's find R Thevenin. Well, when I look at my circuit here, I see that it does not have any dependent sources, so I can just find the equivalent resistance of the circuit to the left side of where I'm applying the load. And when I do that, to find the equivalent resistance, I short out any voltage sources. And now I need to find R Thevenin. Now in this particular example, it's even more important to see why we say we want the resistance as seen by where we're putting that load. Because just looking at what we have left, we just have this square here. Are these resistors in series or parallel? Well, the way it's drawn, you don't have an answer to that. But when I put in where my load is going to be, I can see from the point of view of my load, they're in parallel. They're in parallel because their ends are connected on this side and their ends are connected on the other side. They have the same voltage across them, if there was any voltage that was applied. So these two, from the point of view of our load, are in parallel. If, on the other hand, that's 150 and 30 and RL. If, on the other hand, we had the problem was like this, and here's where A and B were. So if A and B were over here on this side, then we would say, well, okay, in that case, they're in series. So that would be the difference. So R Thevenin will equal product over sum, 30 times 150 over 30 plus 150, or 4,500 over 180, which is 25 ohms. So what's the answer to part A? The answer to part A is the value of RL that results in maximum power is 25 ohms. Now it's asking what is the maximum power that can be delivered? Well, the maximum power is V Thevenin squared over 4RL. Now, V Thevenin, we hadn't found V Thevenin, so now we need to find V Thevenin. So let's go back to our circuit. And V Thevenin is the voltage across these two terminals here, A and B. That's the same as the voltage across this 150 ohm, I don't know why I put volts, this 150 ohm resistor. So because AB is in parallel with the 150 ohm resistor. So I can get the voltage across that 150 ohm resistor by using voltage division. So the total voltage across both resistors is 360 times, and then to do voltage division, I do the resistor that I'm interested in, which is the 150, over the sum of the two resistors, which would be 30 plus 150. So just a reminder what I just did there, voltage division. If I have two resistors in series, like this, and I know the voltage, the total voltage across both of them, so VAB, I'll just call that V, and I'll call this resistor R1 and this R2, and let's say I'm looking for V2. So V2 would equal my total voltage times the resistance of R2 over the sum of the two resistors. And that would tell me the voltage change across this resistor. If I wanted to know what V1 was, V1 would be my total voltage times R1 over R1 plus R2. And that gets you the voltage change. It does not get you what the absolute voltage is, it just gets you the voltage change. So the voltage across the 150 ohm resistor, which equals the Thevenin voltage, is 360 times 150 over 180, or V Thevenin is 300 volts. So now I have the Thevenin voltage, and I have, well, I want the maximum power. So to have the maximum power, to have max power, RL needs to equal R Thevenin, and we found out that R Thevenin was 25 ohms. So we'll use 25 ohms. So then max power equals V Thevenin squared, 300 squared, over 4RL, or 4 times 25, which I think is supposed to be 900 watts. Does anyone do it on their calculator and get 900 watts?
Yes, it's 900.
Okay, good. All right. Okay, and question. Is this going to be posted? I'm planning on it. Yeah,